All right, linear equations, and we had started this last time. We had finished through the example here about scientists and measuring the temperature based on how far away from the surface of a planet that you were. And we're on this example with Jose. All right, so Jose is putting money into a checking account. Good stuff right there. And we're going to let Y be the total amount of money that he has in his account. X is the number of weeks since he's been adding money to that account. And we are told that X and Y are related by the equation 500 plus 40X equals Y. Then we'll have a couple questions to answer about our context. All right, in terms of our equation, 500 plus 40x equals y, we know that from last time, 500 is a y-intercept, 40 is a slope, we get that. But how about in the context of this particular problem? Any idea what the 500 and the 40 represent in context? We'll start with the 500. What do you think the 500 represents?
Starting amount.
Yeah, it is the starting amount in the bank account. Why did you think that, Megan? Okay, it's the point that you would start with, like on the y-axis, and the y-axis would represent, in this scenario, the starting point of the account. Does that make sense to everyone? So that actually answers the first question, part A. What is the starting amount in the account? And the answer would be $500. What is the 40 representing? Right, it's the amount that he's putting in each week into his account. And any idea why, why were you thinking that? Just because it's the other question, Keely, or was there more to it?
Because the X would be the number of weeks.
Right, very good. So X is representing the number of weeks that he's been doing this. So on week 1, we would have an additional, in this case, $40. You'd end up with 500 plus the 40, right? So the weekly change in the money that he's putting into this account is $40 per week. Does that make sense? Cool. So that's a pretty straightforward one where we're identifying rather than creating an equation. We're identifying from it the pieces. Let's try one more. This next one's probably the most challenging one that we've done. It is our last one for this section. Can I switch the screen? Is everybody good? Okay. So example number 8. Suppose that the weight in pounds of an airplane is a linear function of the amount of fuel in gallons in its tank. When carrying 15 gallons of fuel, the plane weighs 1984 pounds. When carrying 35 gallons of fuel, the airplane weighs 2,096 pounds. How much will it weigh with 50 gallons? ideas about how you might start the problem. I give you a lot of numbers. There's a lot of data here. What two quantities are we forming a relationship between? Good. All right, so let's just start by getting some kind of an organization of our details. We are looking at the gallons of fuel compared to the weight of our airplane. Does that make sense? I mean, those are the two pieces of information you're given multiple times within here. So somebody give me one of the corresponding relationships between gallons and weight that you're given. All right, so when we have 15 gallons, we have a plane weighing 1984. What are we measuring in? Pounds. So the weight is in pounds on that one. All right, what's another one that we're given?
2,096 pounds.
Good. Okay. And then the last thing that we are given is something about a number of gallons being 50, and we're supposed to figure out what this should be, right? Are you guys good with that? Cool. All right, so the key to doing this problem and how it fits in our section is that it actually tells you that there is a linear function relationship between these. I can create a line, okay? And each of these quantities are related just like x and y would be related on a line. So if you like x and you like y in terms of variables to use, we could actually call this x and this y. So in a very real sense, we have an ordered pair that looks a lot like 15, 1984, and another ordered pair that looks like 35, 2096. Does that make sense to everyone? Okay. So if I'm trying to create an equation, and we know that the equations we've been working with can all have the form y equal mx plus b, I need to know what is m and what is b. Which one's the first one we would find with the information that we're given on this problem? M, right. I don't know B. B would be the empty airplane, right? And it doesn't tell me that, so I don't know that right away. But I can find M using the 2 points that I'm given. So my M value would be the second Y value, so I'll use the 2096, minus the first Y value, 1984. And I would be dividing by 35 minus 15. So somebody calculate that for us. What do you got? What was it?
28 over 5 is what I got.
Okay. And you can use 28 over 5, or if you want to use a decimal, what's the decimal you have for that, Alyssa?
Yeah, I don't know.
You don't have that? Somebody else's 5.6? I know most of you prefer decimals, so this is one where you could put it in decimal form. If you leave it in fractional form, that's fine as well. So either of those would be good on this one. All right, so I'm part of the way there. I now have y equals 5.6x plus b. How am I going to be able to find what b is? Yeah, good. I need to fill it in with one of my ordered pairs x and y. It doesn't really matter which one. I'm going to use the first one just because. So 1984 would be y equals that 5.6 times x, which is 15. And I can find out what b is. So, what is 15 times my 5.6? What is it?
84.
84. And Interesting. So what's B? Yeah, it's 1900, right? So if I were asked what the weight of the airplane is, that would be my answer, actually, wouldn't it? My weight of my airplane is actually 1900 pounds. It asks me to find out something different, though. It wants to know how much it would weigh if I had 50 gallons in my tank. So how am I going to use what I've done so far to find that answer out? Okay, so you're giving me the exact details. The first thing I would want to recognize is that I could fill in the full relationship now, right? I have a 5.6 for M, and I have the 1900 for B. So this is the relationship between the fuel weight in gallons, right, or volume in gallons, compared to the weight of the airplane. And then I could find out my weight, or my weight of my airplane when I have 50 gallons by plugging in the 50, which is what Megan was talking about right there. So if I put 50 in for X, so 5.6 times 50, and then add my 1900, what do I have for the weight of my airplane? 2,180 what? Pounds. So notice, like, nowhere along the way did it actually say find the equation, right? But that's what we have to do in order to finish the problem out, okay? So it's not really reading between the lines, but it is sort of a sub-goal along the way. We have to get to this point in order to continue and get to the next point that we really want to leave at, okay? Any questions on this one? All right.